Just to explain one more point here, you see total CFM and dehumidified CFM. In this case, total CFM is less than dehumidified CFM. So practically is possible. You see, dehumidified CFM is the air which loses the moisture on the coil out of total air. Okay. So total air cannot be less than the dehumidified CFM. Na? So this is also one key point. We can adjust this. For example, we'll check like this. For example, I'm selecting here and I start with a 54. With a 54, you see 1084 less than dehumidified CFM. It's not applicable. Like this, you need to follow up to 61. The range is 54 to 61. So when I enter 60, for example, you see I'm getting 1489, which is more than dehumidified CFM. Means this is practically accepted. But as per our calculation, we got 59, so I'm entering 59 for this sample project based on psychometric analysis. So you see, you can find out 1402, close to 1400. Na? And the same we got here 1400. 1397, we round off to 1400. Anyhow, plus or minus the 5% is accepted in CFM. So 1400 CFM. So finally, the result is 2.85 TR with 1400 CFM and dehumidified CFM nearly 1200 to select the equipment. Okay. Now some more terms here. TMBH, remember, as a total MBH. What is MBH? Please make a note of this. You can note 1 MBH equal to 1000 BTU per hour. Like 1 kg 1000 grams, no? So we have this conversion. 1 MBH equal to 1000 BTU per hour. So here you see, when I click here, you can verify. I68 by 1000. TMBH is total. Total is here. This value. So this is I68, na? This one I68 by 1000. Here the unit is in MBH. And SEMBH nothing but sensible MBH, sensible heat. And you can verify I54, nothing but the A value by 1000. So you'll find TMBH, SMBH. Generally, we are not using the term LMBH because for machine selection, we require total MBH and sensible MBH. And total CFM is here. And one more unit, 1 term equal to 100 MBH or 1 lakh BTU per hour. Conversion again. This term generally we are using for boilers. One more unit, 1 term equal to 100 MBH, nothing but 1 lakh BTU per hour. 100 MBH means 100 multiplied with 1000. So 1 lakh BTU per hour. So I'll share you this Excel along with the blank Excel so that for practice what you can do, simply change the location. Instead of Hyderabad, you can take your own location. So this delta T, delta W. See, I already shared this Excel with chapter 7 data at the beginning of this topic. Will change. Rest of the parameters same, use as same as sample project. So you can see the difference. For example, if you take for Bangalore, you'll get less tonnage. If you go for say Jeddah, you'll find higher tonnage. Based on that conditions, means outside design conditions. So one more topic is left in chapter 7. Actually, it's a continuation of chapter 7 only. So I added all this in chapter 7. This heating load calculation, manual heating load calculation. So manual heating load calculation we'll do in the next session to conclude this chapter 7. And manual heating load calculation is simple because there is no internal sources and there is no solar heat gain.